Let's run through some properties of logarithms. So assuming that b and x are both positive numbers, we have a product rule for logarithms. The logarithm of b times x is equal to log of b plus log of x. By the way, I'm writing everything here in terms of the natural logarithms. I should also say everything holds as well for other bases, log base a of whatever. A quotient rule. The log of b over x is equal to the log of b minus the log of x. So a quotient here becomes subtraction here. Reciprocal rule. The log of 1 over x becomes negative log of x. And a power rule here, the log of x to the r comes down in front, becomes r natural log of x. We also have some inverse properties. If at any point you have a, the base of your logarithm here, raised to the log base a of x, the a and the log base a to the power and log base a essentially cancel out and you're just left with x. Similarly, if you take the log base a of a to the x, you just have x. If we specialize a to be e here, so log base a is the natural logarithm, this is e to the log x is equal to x, log of e to the x is equal to x. Let's crunch through some examples of this. I asked you to simplify these expressions here. Log of 4 plus log of sine x. So this is adding two things together. Addition of logs becomes multiplication inside the log. So this becomes the log of 4 times sine x. Log of 1/8, I mean, it's perfectly fine to leave it as log of 1/8, but if we wanted to play around with it, to use this inverse rule, it's equal to the negative log of 8. And also, let me just observe here that 8 itself, I mean, this isn't really simplification at this point, but it's just showing there's multiple ways to write logarithms. 8, of course, is 2 cubed. And by the power law, we are allowed to bring that 3 down in front, and so this is negative 3 log 2. Log of 1/8, negative log 8, and negative 3 log 2 are all equal to each other. Finally, let's say we want to simplify log of 5 minus 2 log of 6. Well, now I'm going to take the 2 and move it upstairs, going in this direction here for this power law. And so log of 5 minus the log of 6 squared. 6 squared is 36. And now I'm going to use the subtraction rule here, the quotient. Subtracting 2 logs becomes a quotient inside the log. And so this would be a log of 5 over 36. Okay, a few more things here to simplify. The log of the log base 10 of 10 to the e. So now we're using here these properties. Log base 10 of 10 to the e. Log base a of a to the x. So this expression here equals e. Log base 10 of 10 to the e is e. And then, this is e to the 1. The logarithm of e to the 1 is just 1. Now we're using this rule down here. Log base 2 of 48 minus log base 2 of 6. So in this case, we are using this rule here. So this is log base 2 of 48 divided by 6. Of course, 48 divided by 6 is 8. Log base 2 of 8. And we can rewrite 8 as 2 cubed. We did that about 60 seconds ago. And so now we're coming back here, log base 2 of 2 cubed. Log base 2 of 2 cubed is equal to that exponent there, 3. Okay, and then finally, e to the negative 2 log 3 plus log of 36. The thing that we want to do here is that we want to use this expression. If we can rewrite this as e to the log of something, we'll be in business. By the way, let me just point out here that this is not equal to, the temptation might be to say something like negative 2 times 3 plus 36, and say, oh, you know, the e cancel that log, the e cancel that log. This is not allowed. The thing is that we need to rewrite this as e to the log of something. So our goal is to take this exponent here and write it as log of something. How do we do that? We are going to be using these rules here, and this one as well, that 2 goes upstairs. So this is e to the negative log of 3 squared is 9 plus log of 36. And now we are going to use log of 36 minus log of 9 is log of 36 over 9. And of course, 36 over 9 is 4. And so what do we have here? E to the log of 4. Now we can use this inverse rule here to simplify this down to 4. Okay, one more interesting little exercise here. Suppose I tell you the log with base square root of a of 106 is equal to 2. What is the fourth root of a minus 25? So this might look intimidating at first, but let's just remember, what does it mean? What does this here mean? It means that if we do let's see here, square root a to the second power, square root a raised to this power, we get 106. Okay? Well, square root a squared is just going to be a. You know, that's we know that a has to be positive here. If a is negative, we're going to run into trouble when we're taking the fourth root of a minus 25. And so now we can plop this in up here. And so we have the fourth root of 106 minus 25 is the fourth root of 81, and that is 3. So hopefully this is some instructive examples here working with logarithms.